Okay, our next speaker is Doug Lee. Probably many of you already know Doug. There is no need for introduction, but Doug is a professor at SUNY Oswego. He is a primary developer of several widely used packages, and he is the author of great books such as Concurrent Programming in Java and Object-Oriented Software Developing. Today, he's gonna talk about thesis design and engineering trade-offs. I'm so excited about it. Doug, please go ahead.
Hi, thanks. So this is a talk on this really oriented towards viewers, audience that's a little bit less far along than the people who have been presenting all morning, but maybe they can see what decisions they've made through it. A little bit of background. I often am in the mode of thinking about engineering trade-offs in all sorts of ways, including about PhD theses, in part because I'm at an institution without a PhD program, which makes me the easiest mark in the world for being an external committee member. I have been on almost 30 of them over the past 20-something years. And so it's a little bit easier for me to stand back and see these things when I'm a little bit of an outsider. So I'm going to start with something that is just an observation that was made in a really good but completely obsolete software engineering text by David Lamb, who started off the first paragraph of the book saying that what you're doing when you're engineering is trading off quality, productivity, and innovation. Doing things well, doing things quickly, doing things at all that had never been done. And that turns out to be about as good a guide to engineering and developing a thesis as a hunk of software. You can translate those sort of obviously. The quality is really the analytic side, what the depth of understanding of a concept. The productivity part is building and building something that you can in turn into programmatic research programs. Creating a basis and then running with it with a series of publications, a series of software releases, and so on. Or the exploratory part where you say, hey, I have this weird, crazy little bit of an idea that I don't think has been done before. Let's flesh it out. And there's some of each and every thesis. So there's a tension about writing, investigating literally everything there is to know about something, and or creating a staircase that you can keep climbing and using the thesis as a stepstone for later work. And the notion that, probably something in your thesis ought to be new, and probably it's the discovery of a new problem rather than the immediate discovery of a new solution. So that's the theme, and I'm just going to walk through parts of it. This is a one idea talk. You have the idea. I'm just going to flesh it out. So if you're focusing on analytics, which is a common thing to do in PL circles, your goal is to say literally everything there is to say about a topic. And some of these are among the most valuable theses ever. Truly terrific works of those that come to mind that are just all over the map because they occur all over. last year, someone, Heidi Howard, did everything you could ever want to know about Paxos in a thesis, just like the, the best source to find out anything about consensus, the Paxos consensus algorithm ever. Several of Steve Blackburn's students have done everything you wanted to ever know about zeroing memory in a garbage collector. Completely great, because nobody else would put all that in one place in print, but you can do it in a thesis. So the challenges are, find something that has a lot of stuff to analyze, but hasn't been done before, and meaning it's sort of near the edge of what people have done. And finding those edges is sometimes just realizing, oh, we've been doing this forever and nobody actually understands it. And there's quite a lot of that in PL systems. It's by definition narrow. If you're going to say everything there is to know about X cannot be, world peace or preserving democracy or other critical things these days. And the main goal is to inform the reader, saying, well, we now know some positive and negative properties. And the negative properties are among the things you can do in a thesis that you cannot get away with in real life very often. Theses are a great place to put negative results, a great place to put, I tried this, it didn't work, here's a little postmortem. I often say that theses and poster papers are the best places to look for like ideas that you might have that didn't go anywhere, because they don't make it in most publications. And that's really too bad, because it's really informative to say, oh, I have this little idea, I'm gonna push it through, and you find out later, well, yeah, someone else tried it and it didn't work for them either. So record your mistakes is sort of an important part of it. Everything I said, it goes across, whether you're a formalist, whether you are an algorithmist, whether you are dealing with things empirically, whether you are doing empirical software engineering. Each of those, so empirical analysis, if you're doing memory management, is the only game in town. There's not a lot of formalisms there, but deeply understanding time-space trade-offs in garbage collectors, really worthwhile. The contextual part of engineering, especially as it deals with processes, and especially as the way people develop software is rapidly changing, if nothing else, because everything is remote. So these sort of contextual things are worth deeply understanding. Sorry. Geez. It's one of my landlines. All right, so the next trade-off is, okay, you want to maybe trade off how deeply do I understand with something with how can I take steps so that I don't just do this thesis, I do stuff after my thesis. The slogan is your PhD thesis is never your best work, it's just your first work. And so bearing that in mind leads you into the let's build a story. And this is very common advice. It's the advice of, well, do enough to publish a workshop paper, put a poster, and then aim for another conference paper, and so on, and build yourself up through a PhD program. And this means a really different kind of focus than the purely analytic, I want to tell you everything all at once kind of thesis. And it's by far the most common path. I have a lot of sympathy to the what's a PhD thesis? Well, you just staple together, 4 publications and you say that's my thesis. If they're heading in a direction that you're pretty sure you want to go in, then that's great. The main issues are if you're like a normal person, initially you're working really close with your advisor, and then you find out that you're not your advisor, and you actually don't have exactly the same interests, and you evolve into something further. And your advisor really ought to encourage that because it's just good for you and good for them. The downside is, well, if you're going to do this and you're working on anything that's sort of an empirical study, that means you invest in some startup. You put together a framework, a platform where you can keep evolving it. Again, concurrency and memory management are really good examples where people build small frameworks and then they build upon them and they write papers about the interesting things they found along the way. The tough part here is the overinvestment problem, which we actually touched on in the last talk. Is you need to make as much infrastructure as you need to show actual empirical comparisons and things like that. But you do not want to spend the rest of your life replicating, to pick on Leanne, and Android Studio. This is a hard call. Note that I'm not giving you any solutions here. All I am doing is enumerating trade-offs. And the final part is, well, there's got to be something new because that's just how this game works. And the main point of this slide, and what I'm going to say next is, the most successful of these are discovering new problems rather than new solutions per se. Finding a problem that people don't know even exists is a surefire good recipe. In part because other people don't know the problem exists, they're not working on the solution. So you have a little bit of runway before the field comes crashing down on you, because once a problem becomes overly exposed, people run to it. So we see this over and over again in the OOPSLA, PLDI, ECOOP community, where nobody's working on X, and then a year later, everyone's working on X, and you go from 0 papers published on the topic to, literally 3 or 4 people working on exactly the same issue all at once is a pretty common thing to happen. As a frequent paper reviewer, I see this all the time. The best place to come up with problems is finding problems in existing work. The tough part here is that most of the easy flaws were easy to see. So there are many theses who have a misunderstanding of the actual problems in some existing solution that don't get too far because they weren't really identifying the actual flaw. They were finding something that was a consequence or symptom of it. Often the way to say to build a solution is a language, a component, an algorithm. In other words, componentize this idea. The idea is an idea in some abstract sense, but by phrasing it as, well, here's a special DSL for X, or here's a type system that, that captures a new form of delegation, or here's a component that if you had it, you could marry reactive and synchronous communication styles, whatever. So the idea is, if you can componentize an idea, then you can move across past it into developing an actual thesis. Across all of these, comparison is the name of the game. Right? If you have a thesis, you need to be able to compare what you're doing to something else. And often it's empirical, and often that means that real life intercedes, and that that you might find that there's a huge variance. You have to narrow down exactly what your claims are. The biggest sin is insularity. You compare something to variations of itself, and nobody likes to see those. My least favorite thing to say about a paper with empirical results is, well, this is all great. You showed the 40 variations of the same idea, but you didn't compare it to anything else existing in the world. So I have no idea what the baseline is. Happens all the time. Don't do that. Similarly, let other people make those comparisons. So this is a line, a bullet that need not apply anymore, because when I first, this is a variation of a talk I've done before. When I first did it, there weren't any things like artifact evaluation committees. Yeah, just do it. And finally, some things just don't work out. Make a plan. And maybe your plan is, oh, I'm finally going to watch Jan Vitek's keynote from Monday, Splash 2020, where Jan talks about entire research projects that built up and crashed down, and how he still got the senior ECOOP award. All right, that's the talk. I'm really happy to take questions and comments and things. I'll pull this down.
Thank you very much, Doug, for the wonderful talk. Are there any questions? Okay, I have a very general question regarding the planning for writing a thesis, because I count myself still as a junior PhD student, and for me, writing a thesis is something which is really far away for now. I don't know, is it something that you really need to think about the storyline and everything from the beginning, and you need to build up everything from sections to sections, and from you need to have a very concrete storyline from the beginning to the end, from the first? Or is it just something that you do stuff, and at the end then you make a storyline based on them and then you write them down? Could you please elaborate on this?
Yeah, I think people ought to have really flexible milestones about things, because you're almost surely wrong where you're heading if you're writing a thesis and you haven't, it's like when you're developing a big chunk of software for the first time. All your schedules are wrong. All your metrics are wrong. And it's good to have milestones, but the milestones ought to have a meta level of let's do a sanity check here. Is this still where I'm heading? So could whoever is the person in charge cause me to unpresent? It seems not to want to do it for me.
Let me see whether I can. I think currently I am host. I didn't know. I need to figure out how I can do that.
Yeah, it's just not listening to me when I try to not present. I wonder what happens if I clobber.
Let me say stop sharing on you. I don't know what happens. I hope you will still be here.
Yes, yes.
Magic.
Okay, good, thank you.
Great, thanks. Are there any other questions?
Can I ask a question?
Sure.
Yeah, sure.
Yeah, thank you for your talk, Doug. I'm very curious about your point about over-investing of infrastructure. So can you elaborate a bit on this? Like any examples, and is there any sort of threshold for when to stop, or at least you believe it is good to stop at some point?
Yeah. Long ago, I was on a committee with someone who invented the notion of Java obfuscators and used it as the basis of their thesis. But of course, they got commercialized in the midst of it. And so the student basically left without finishing, which was a terrible thing. And through a lot of help and work, we eventually got him back on track to finish it. And the sad thing was, to finish the thesis part was a bunch of analysis on properties of obfuscation and making sure that they were semantic preserving. And he found in the thesis that it wasn't in one case. And so, if he had only finished it, he would have known better. Yeah, so this is where developing some infrastructure to work on your thesis. Okay, it was a good story, he's a happy person, but it's a bad story in that it was sort of a little bit of a failure as a thesis. And had it not been commercially viable, then it would have been a bad story all around.
Thank you very much.
Any other questions? Okay, then. Oh, sure.
I was asked Doug a slightly sarcastic question. Where were you in 1996? When I was 3 years into my thesis. That was a great talk. Thanks a lot. And I think it's really good advice to people to think about how to engineer those 3 trade-offs. I hadn't seen that said so crisply before, because you do make lots of these trade-offs of what you're doing, and you're never going to be perfect. You need to finish. So it's just, it was a good, really nice talk. So thank you.
Yeah. I think that the main moral is really it's engineering. You're making trade-offs. Stop pretending you're a scientist if you're in computer science, right? You're an engineer. Ooh, no one on the panel is going to be able to hit me from this far away.
Yeah. Oh, there's a question. There's a silent question from Julia in the chat. So she says, sometimes completely new problems are hard to get published when there's not much related work. Could you comment on that?
Yeah. I truly think, I guess I didn't say this, I truly think that if you do what you love, you always succeed. And I'm hopelessly idealistic about this, but I just see it as true in innumerable ways. That and in fact, Jan's keynote Monday reminded me of this. He's like all these like stories about failures of things, but really, Jan did what he loved and got away with it. Anyone can do what they love and get away with it. So if you're really, if you're doing something really worthwhile, it'll work out. I don't know how. It's like my Pollyanna self.
Okay, then thank you again, Doug, and thanks everyone for being here for the third session. I think that was it for this session. We are gonna be back in 55 minutes, I think, for Ben's talk. See you all in 55 minutes.
Bye.